10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes.
So as a child, I dreamed to fly. The dream of flight has captured the minds of numerous scientists, filmmakers, and artists. With the Apollo missions, SpaceX, and million-dollar budgets of Star Wars movies, flight, especially through rockets, seems out of this world to most people, until now. This is my 3D printed rocket. It weighs about 200 grams, uses a D12-5 motor, and is made of normal PLA. It prints in 8 parts and millions of different color patterns. It's easy to assemble, but extra parts are needed. I used hot glue to stabilize the fins in place. I used Gorilla Glue for the launch plug and glue for the fuselage. I used screws to mount the motor in place, and a big black trash bag for the parachute, along with rubber bands and kite string. More on that later though, but before we dive a little bit deeper, let's learn how rockets actually work. So Newton's third law of motion is for every action there is an equal and opposite reaction in the opposite direction. So when you shoot a firearm, as the bullet flies out the gun, a motion will be produced as a reaction against your shoulder and fling it backwards. This is known as a recoil. So as a rocket motor is burning, it shoots hot gases out the end and at high speeds. And like a gun, the rocket moves upward as the gases shoot in the other direction, downward. This is the basics for any rocket. Model rockets have some specific features in order to work properly though. A model rocket motor has 3 important characters that show its characteristics. The letter in front shows the amount of thrust it will produce. The second number shows the average thrust it will produce, and the last number shows the time delay to deploy the parachute. A D motor is needed for the rocket because of its weight. Between the motor and the parachute, the fireproof paper called the recovery wadding must be used to protect from the fire of the engine. The parachute is connected to the nose cone, and the nose cone is connected to the body by a rubber band. The little cylinder on the outside of the body is the launch plug, and it is used to direct the rocket through the takeoff. To assemble the rocket is very straightforward. The fins slide into the 3 grooves on the rocket. The lower fuselage needs to be Gorilla Glued to the upper fuselage right there. The nose cone needs to be glued to the upper fuselage with a strong rubber band. And the motor mount must be screwed into place into the lower fuselage, and the launch plug will be glued to the upper fuselage using Gorilla Glue. So when you fly the rocket, make sure you are in a big park or area away from people. A D motor is a higher end hobby motor, and if a rocket malfunctions, injury could occur. So fly at your own risk. With that out of the way, you will need a takeoff platform and a pole, like this shown right here. The motor should come out with a plastic tip and an electric igniter. Put the ignition inside the motor, and then cover it with the cap. Clamp the 2 wires to the ignition and walk away as far as you can from the rocket. Put the pins in the rocket controller to activate it, and do a countdown before you push the button. Watch the rocket take off. Hopefully the flight went smoothly. Recover the rocket and repeat. Okay. Hope you enjoyed the video. If you enjoy engineering and programming, please hit the subscribe button. The more people who subscribe, the more videos I will produce. So let me know if you have any questions in the comments. And if you want the STL files, or if you do not have a 3D printer and want the rocket, visit my Etsy at etsy.com/shop/innovative invention. and thanks for watching.